All right, so today we're going to do notes on 7.1 and 7.2. It's kind of mixed. We've talked about a lot of this in chapter 6, so some of it'll feel like repeating. Pretty much we're just going to keep learning the same kind of concept over and over, just seeing different points of view, really, different ways of thinking of it, more geometrically, more algebraically, special right triangles versus the unit circle, that sort of thing. So kind of going back to the paper plate we did the other day, that was the unit circle. Sometimes you'll see books that call it the trig circle or trigonometric circle. It's the same exact thing. Really, the whole reason it's so useful is because it lets us calculate sine, cosine, and tangent relatively easily when we're talking about angles between 0 and 360 or 0 and 2 pi. And that's why it's so important to get something that's coterminal if our angle is too big or just too negative. But kind of a little refresher on that. Remember, the unit circle is called the unit circle because the radius is 1 unit long. And we can think of that as being centered at the origin on an xy plane. So if we think about the circle itself and go back to geometry, the formula for a circle in geometry was x squared plus y squared equals r squared as long as it was centered at the origin. So r squared would be 1 in this case. So that's really where that formula is coming from. It also comes from the Pythagorean theorem, though, because if I were to take really any of these angles and drop down an altitude to create a right triangle, our radius is 1, and we have an x and a y here, so that's where the leg squared plus leg squared equals hypotenuse squared Pythagorean theorem is really coming from. Also notice there's a whole bunch of points. All these yellow points on the circle, remember, are representing really that cosine and sine pattern. So that's really, really useful if we can memorize these or use the left-hand trick and figure out, what quadrant am I in, to really quick get answers for sine and for cosine. All right, so this next bit is going to look very similar to something we've already seen. It's just instead of t, we had used theta. So that's because in section 7.2, what they're saying is more looking at the arc measure than actually looking at the angle itself. But if you remember from geometry, if I have a central angle, which is what all of my angles are, if I have a central angle, then the angle of the arc measure angle is exactly the same. So it doesn't really matter whether I call this t or I call this theta, whatever. It's really the same method of finding the answer. It's just really what is that representing. So if you take a look at this picture down here, what you can kind of see is when we're saying t, we're really kind of talking about the arc as opposed to talking about the angle. But since the measure would be the same number of degrees or same number of radian, it doesn't really matter in terms of finding our answer. It doesn't make a difference. You'll also note that sometimes you'll see that instead of trig functions, they'll call them circular functions because they have to do with circles. It doesn't really matter, just a different phrase. But these should look very similar. So if I were to do this in terms of a triangle, like we had kind of dropped down that triangle before, and it might be a little easier to see in the first quadrant. So if I had my triangle here, right, here's my angle, and so I have an x, a y, and my r. So if I were to take the sine of it, that would be opposite over hypotenuse, or y over 1. So that's where the y is coming from. And these guys, remember, are just reciprocal functions, so I've just flipped it over. Same with cosine, adjacent over hypotenuse. So again, x over 1 or just x. And then opposite over adjacent is going to give me that y over x. And cosecant, secant, and cotangent are all just my reciprocals. Okay. All right, so in the next one, all we're asked to do is just to find the 6 trig functions. So we want sine of pi over 3. We'll do that one first. Cosine of pi over 3. Tangent of pi over 3. Then we've got cosecant, secant, and cotangent. Okay. So we need to, first of all, what might be useful is to use your hand trick. That's certainly one way. Oh, that is the worst hand ever, but yeah, that's terrible. Anyway, that's a pretty good kind of method here, right? So we've got our x and our y, so that's 0. This is pi over 2. This would be our pi over 6, pi over 4, so pi over 3. So if you were to put if you have your left hand facing you, palm up, you'd put your pointer finger down, and we would get 1 on the left and 3 on the right. So that would tell us that we would have that our point for this one would be 1 over 2 comma root 3 over 2. So that means that our cosine is 1/2, and that our sine is root 3 over 2. Okay. Also, don't forget another way of thinking about this cosine sine. I like to remember that when this is a point x comma y, it's in alphabetical order. Well, sure enough, cosine sine is also in alphabetical order. So for me, that's kind of a nice trick, whatever works for you. To get tangent, we just do sine divided by cosine. So if I do sine divided by cosine, that would be root 3 over 2 divided by 1 over 2. The over 2's cancel out, so I just get root 3. And then to get the bottom, we just flip it over. 2 over root 3, which is really 2 root 3 over 3. And 1/2 becomes 2, and root 3 becomes 1 over root 3, or root 3 over 3. Okay? And we can do very similarly for pi over 2. So for pi over 2, we've got sine of pi over 2, we need cosine, we need tan, we need cosecant, secant, and cotangent. Okay. So in order to do this one, again, I think the left-hand trick might be a good one. Pi over 2 is really that, oh my gosh, my hands are just getting worse and worse, aren't they? I'm really not an artist. Anyway, pi over 2 is up here. So if I were to put my thumb down, that's going to give me 0 on the left, but 4 on the right. Remember, it's radical over 2. So 0 is really going to give me 0. And root 4 is 2 over 2, so I get 1. So that's the point, 0 comma 1. So cosine is 0 and sine is 1. Well, if cosine is 0 and sine is 1, tangent would be 1 over 0, but what is that? Well, that's undefined, right? It can't divide by 0. It's okay to have 0 on top, but it's no good to have 0 on the bottom. All right, cosecant, when I flip 1, I get 1. When I flip 0, I get 1 over 0, which is undefined. And when I flip 1 over 0, I get 0 over 1, which is just 0. Okay. So notice that 0 over 1 is reciprocal with 1 over 0, which is undefined. Okay. So 0 and undefined are going to be reciprocal to each other. All right. And just kind of a quick review. Don't forget about the left-hand trick being really useful. You can kind of see those numbers showing up here. To the left is cosine. To the right is going to be sine when you have your leftover fingers. And all students take calculus is always a great way, if you're going to use the left-hand trick, to then determine, should I put a plus or a minus sign on it? And kind of just explaining, kind of going back, what happens in each quadrant with all students take calculus. First quadrant, everything is positive no matter what. Second quadrant, sine and cosecant end up being positive because that's really just flipping the number over. So the reciprocals kind of go hand in hand. But so all students take calculus. That's because sine, tangent, and cosine are positive in their respective quadrants. Okay. And we've filled this chart out before, but just so you can kind of see it, you'll notice that when we have 0, then the reciprocal ends up being undefined. So that's what that dash means. We can't get an answer there. Whoops, that is something that's undefined. Sorry, too close to the edge there. Okay, same thing here. We'll see that when we get 0, we get undefined, and they, match up. Okay, all right. So, even in odd properties, I want to just think back just a little bit back to when we were learning about polynomials. So at one point we had to determine, I don't even remember what marking period it was. Might have been first marking period. I don't really remember. But to determine if a polynomial was an odd or an even function, what we did was take the function first. So let's take, I don't know, like this maybe. And what we did was replace x with negative x, and if it gave us the exact same answer, it was even. So if I plugged in negative x here, does this hopefully ring a bell a little bit? When I do to an even power, that negative just kind of disappears. Since this looks exactly like this, we get that f of negative x is equal to f of x. It's the exact same thing. That tells me I have an even function. If I were to take a function, say maybe x to the 5th plus 2x to the 3rd plus x, something like that, and I were to plug in a negative this time, what you'll notice is it does not stay the same. In fact, something very specific happens. So that actually gives me negative x to the 5th minus 2x to the 3rd minus x. And if I were to factor out an x, that would be, sorry, factor out a negative. I know I could take out an x, but let's just take out the negative. That would give me x to the 5th plus 2x cubed plus x. That would give me a negative and then the original function. So that would be negative f of x. It's like when I plugged in the negative x, I could have just pulled the negative out front, and that gave me an odd function. So you're going to notice something special happens. Some of our trig functions are even, some of our trig functions are odd. So let's take a look at sine of pi over 6, and I'll tell you in a little bit which one's which. But let's start with sine of negative pi over 6. So if we start with that one, sine of negative pi over 6, first thing I want to figure out is what quadrant is it in, right? So I do all students take calculus. Okay, and we're doing a negative pi over 6. So negative pi over 6 means I have to go down, right? So that's going to put me in quadrant 4. I would go down first, but it's smaller than the pi over 2. So it would be somewhere down here, okay? All right, so that means that my answer is going to be negative. Well, what's my reference angle? Negative pi over 6, I'm going to think about pi over 6. So now whether I use the left-hand trick or I draw a special right triangle, it doesn't matter. Either way, I'm going to say, okay, pi over 6, that means for sine, I'm looking to the right if I'm using if I'm using my left hand. So I'm going to get 1/2, okay? So I get negative, and I'm thinking, what is sine of pi over 6? And I'll just stick a negative on it. So I'll get negative 1/2. Well, look at it this way, right? I took sine, okay, sine of a negative, and it's the same as taking that negative and putting it out front. That makes sine an odd function. Okay. Let's take a look what happens with cosine. So cosine, all right, so all students take calculus. Since that's a negative acute angle, I'm still down in this quadrant. Pi over 4 negative will be somewhere down here. All right, pi over 4. So my reference angle is pi over 4. Cosine this time is going to be positive. So really I'm just saying, okay, whatever pi over 4 is, cosine of pi over 4, that'll give me the same answer. Cosine of pi over 4, I put my middle finger down, so that gives me root 2 over 2. And it's positive. So the answer to cosine of negative pi over 4 is exactly the same as positive cosine of pi over 4. It's the same. Plugging in the negative doesn't change it. That makes it an even function. If we do tangent, which it didn't ask us for, but if it did, we would notice that tangent is an odd function just like sine. So cosine and its reciprocal are even functions. Sine cosecant, whoops, I wanted to change the color. Sine, cosecant, tangent, and cotangent are odd functions. What's nice about that is in pre-calc, it'll really help you to kind of simplify expressions with trig. Okay. All right, so let's take a look at finding these 6 trig functions, and we're going to use the given information to try to figure that out. So we could draw a triangle if we want, but we don't necessarily have to.